Welcome back. This is sequence 3 of the course, and we learn why we have chosen OCaml by listening to the voices of users, real users, and understanding why they are so excited about this language. So who uses the OCaml programming language? Of course, it is used in teaching in many universities, naturally in France, where the language was born. You have many universities in Paris and all around. In Europe, various universities in different countries, in Italy, in Denmark, in Poland, in Austria. In the United States, in prestigious places like Cornell University, Harvard, or Massachusetts and Pennsylvania, and many other places. But here we are more interested in learning why it is used in advanced research projects. The Coq-Rufer system, which was awarded the Software System Award by the Association of Computer Machinery just last year, the Astrea static analyzer, which is used daily to verify the command and control code of the Airbus A380, the Framer C platform, which performs advanced analysis of C code, Oxygen, which is a revolutionary way of writing web applications, Altergo, a SAT modularity solver, Mirage OS, which is an incredible achievement, developing a kernel as a library that you can bind directly inside your system, in your application, to run the application on bare metal, or Flow and Hack, which are PHP or JavaScript type checkers. Yes, we are type checking other languages, but the type checker is written in OCaml, it's fundamentally written in OCaml. And this is a project coming from Facebook, and many others. And then you have industry using OCaml for advanced and sophisticated application. Of course, you will find finance application, Bloomberg, Jane Street, Lexify, but you have aerospace systems like Dassault Aviation using this. Then you have virtualization of cloud, Citrix, operating system, Microsoft Red Hat, and various others. So it's very interesting to hear what all these people say. We asked many of these people to provide us a quote for this course to explain why they have chosen the language and why this is important for them. So let's start with Astrea, which is used to ensure safety of critical embedded code. So Antoine Minier, which is a researcher, one of the main contributors to the Astrea system, told us that the language was essential to develop a system as sophisticated as this analyzer because it's type-safe, it's a functional language, it's robust, and has a high-performance native code compiler, which is important when you have to verify millions of lines of code written by smart AIs. Then you have mechanized proofs. We said the Coq-Rufer system, which was awarded an important prize, is integrated in OCaml too. And the code development team told us if they really need to choose one particular feature of the language is essential for them, that was pattern matching, because otherwise implementing complex symbolic computations would be really a nightmare. So TrustingSoft is a startup that provides groundbreaking technology for checking safety of software which is used in security applications. For them, OCaml is fundamental because it is efficient and it is expressive. I mean, they need efficiency because they are working at the frontier what is technically possible today. They need expressivity because they are, again, developing sophisticated analyzers, so they need to be concise. And they need static type checking because that way you can avoid an incredible amount of errors. But then you have also next generation web application like the Oxygen framework. Vincent Bala, which is a creator of Oxygen, considers that thanks to the OCaml type system, Oxygen can do incredible things like checking statically. This means when you compile it, that a web application will never generate invalid HTML pages or that a form really has the fields which are expected for the application to run. And he also thinks that the type system is extremely powerfully useful for refactoring a large project. When you need to change the data definition and adapt the program to the new data definition, the compiler really points out every piece of code that needs to be modified. And this, for them, is life-saving. Saves days of testing and debugging. Then you have OCaml Pro, which is a professional company that specializes exactly in OCaml development. They are the best one in town you can find if you need to have some OCaml development be done. And again, they point out that what is fascinating compared to other languages is that in OCaml often you just define the type of your data, and then naturally, gently, the compiler will drive you towards the development of the right program very fast. And for them, this is really fascinating. We really hope you will get a taste of this power during the course of this MOOC. Cryptography. In cryptography, you have another startup which is called CryptoSense. They develop software which is used to assess vulnerabilities in cryptographic systems. And for them, OCaml is a strategic advantage because they can produce quickly software which is, for them, high quality, readable, and reusable. Finance. Here you find LexiFi, which is probably one of the earliest industrial adopter of the OCaml language. They create innovative software for managing complex financial products. And for them, beyond safety, readability, expressivity, and great performance, which are mentioned by many others, it is really important to be able to have a portable system. They have clients using Unix, Windows, or even just a web browser, and they are able to deploy their product across all the line. And I'm very happy to see there is a growing interest and activity around OCaml today. Now also in operating system, here you find Mirage project, which is a fantastic undertaking to write a full exokernel or unikernel entirely in OCaml. This means they are going to write every functionality which is needed by an application to run on bare metal, I mean the pieces of operating system, we can be linked directly inside the application to be order of magnitude faster than an application just run through an operating system. This has already been done, and it has done entirely in OCaml. For them, the combination of static type safety and fast native code compilation are fundamental for doing this operating system level development. And finally, we can also mention a very interesting paper. I do suggest that you go and get this communication of the ICM in September 2011. Yaron Minsky from Jane Street wrote a paper which was called OCaml for the Masses, explaining why Jane Street, which is a company that builds financial trading tools that handle $10 billion per day, 2% of all financial transactions around the world, and run them through software written entirely in OCaml. For them, it's really important to be able to write smaller, simpler, easier to understand system than using other languages, for a very simple reason. I mean, if you have a smaller piece of code, you have less chances to have bugs. That's clear. For them, for an organization like them, where a mistake can cost you millions of dollars, this kind of features are fundamental. And also for them, the type system is really fundamental to find bugs which are hard to get through testing directly. And finally, virtualization and cloud computing. You have Citrix with Xen hypervisor. I mean, all the tools around Xen hypervisor are also written in OCaml. Richard Schaaf from Citrix told us that OCaml has really been key to bring productivity and efficiency improvement in their development. So to sum up, there is a wide variety of users in the OCaml language, from teaching to research to industry. And if you look at all these quotations, you will see that all of these people unanimously value the safety which is brought by strong static typing and by pattern matching, the efficiency of a high-performance compiler. You just don't want a safe programming language and then slow programs. You also want fast programs. And expressiveness, which is really this magic combination, this magic triangle we have seen in the previous sequence, of a functional language with type inference, polymorphism, and abstract data types. We'll see a quick selection of the examples to get a taste of all this later on.